Hello students, in this video we'll study about the methods to find out area of triangle and circle. In the previous videos we devised the formulae to find out area of square, rectangle and parallelogram. So let's move ahead to find out the formulae for the area of triangle and circle. Here we have two triangles. This is equilateral and this is your obtuse angled triangle. Whatever may be the triangle, whatever may be the type of the triangle, every triangle can be easily completed into a parallelogram. How come? We just have to draw a line parallel to this from here and one more line parallel to this from here, like this. This is parallel to this and this is parallel to this. So this triangle has been completed to a parallelogram. Here also a line parallel to this can be drawn from here like this, and a line parallel to this can be drawn from here like this. So both the triangles are completed to a parallelogram. And one more point of observation is there. And what is that? That the area of this triangle here, blue triangle, is equals to area of this triangle. If we fold them up, this figure at this axis, they will overlap each other. That means the area is same. Here also the area is same. What does this mean? That means this area of triangle is actually half of this parallelogram. No? Because the two equal parts of this parallelogram are this and this. So in that sense, this triangle is half of this parallelogram. Also here, they are the two equal parts of this parallelogram. So this triangle is half of this parallelogram. This actually means that the area of a triangle is half of the parallelogram. No? So now it's easy to devise the formula. How come? What is the formula for area of parallelogram? We know that if we have to find out area of parallelogram, if we have to find out how many squares are there in the parallelogram, we just have to multiply its base with its corresponding height. Any of the base, either this or this. Let's suppose choose this base. Okay, so what will be the area? The area is gonna be this into this height. No? Base into this height. So what will be the area of this triangle? That is gonna be half into base into corresponding height. No? So area of triangle is half into base into corresponding height. What is the base? This is the base. You can say this is the base for the parallelogram, or you can say this is the base for the triangle. No? And this is the corresponding height. No? The height on that base means the height to which the figure has been raised. So parallelogram starts from this base and ends till here. Even the triangle starts from this base and ends till here. So the base of a parallelogram is actually the base of a triangle, and the height of the parallelogram is also the height of the triangle. Okay, so base into corresponding height was the formula for the area of parallelogram, and the area of triangle will be half into base into corresponding height, because the area of triangle is half of the parallelogram. So okay, so did you get to know? Area of triangle is half times the base into corresponding height. Again here corresponding height, because this can be the base, then you have to choose the height corresponding to this base. No, as in the previous video we found the height corresponding to each base. No, there we had two bases of the parallelogram and we have the two heights. So similarly here we have 3 bases for the triangle and we can have 3 heights. Okay, so this was the area of triangle. Next is the area of circle. How to find out area of circle? So far we have the formula for area of square, rectangle, parallelogram, triangle. What to do with this figure? How to find out its area? So here the way out is we'll divide this circle into triangles. Okay, so I'm just dividing it. So here I have one side and the other side. Can you say this is a triangle? No, because the third side is not the line segment, it's actually the arc. Such a figure is not triangle, it is called sector. So, can we find out its area? No, we do not have any formula for the area of sector. So far we have formula for area of rectangle, square, parallelogram and triangle only. So we cannot find out the area of this sector. So let us try to find out triangle inside it. Is this a triangle right now? No, it is still an arc, so this cannot be considered as a triangle. Now, still it's an arc. But if we keep on dividing the circle into smaller pieces, just like this. So for very small triangle, this will not be arc. This will become a line segment and this can be considered as the triangle. This portion can be considered as the triangle. Okay, so now we can find out the area of this triangle. No? The area of a triangle is half into base into corresponding height. As we made a triangle here, similarly we can make infinitely small triangles in the full circle. So what will be the area of this full circle? That will be actually the area of triangle 1, triangle 2, triangle 3. No? What do we have to do actually? We actually have to divide this circle into very small triangles. No? Very small means that small that the third side is not an arc, it's a line segment. So we can divide this full circle into many triangles as I have done here. How many triangles will be made there? See, we actually have to make very small triangles. So infinitely many triangles means at least many triangles, if not infinite, many triangles can be made. We don't know how many, but they're many. Okay, that depends upon the size of the circle. Bigger the size of the circle, more and more triangles we have to make, so that this third side is actually the side, not the arc. Okay, and the area of full circle will be equal to sum of the area of all the triangles. So area of circle is half into base 1 into height. No? What is base 1? Base 1 means base of triangle 1 and the height. And what is the height? From here to center. So height of all the triangles are gonna be same. This triangle also, this also and this also. Huh? So half of the area of second triangle is half into base 2 into height. Half into base of triangle 2 into height. Height is same, that is why I have not written h1 and h2. Okay, and the third triangle half into base 3 into h, and so on all the triangles. And the last triangle, I will not give it any number. I will call it nth triangle. Just like it was first, second, third, I will call it nth triangle because I don't know how big is my circle and how many triangles will be made. So I'll say n triangles will be made. So nth triangle is, so area of nth triangle is this. See, now what am I doing here? Area of first triangle is this. So it's half into B1 into H. I can call it half H into B1. No? I can call it half H how many times? B1 times. Again here, half H how many times? B2 times. Half H how many times? B3 times. So I can call it actually half H B1 plus B2 plus B3 plus Bn times. No? Just like if 10 is 15 times and 10 is again 5 times, so we can call it 10 is 20 times. No? Somebody gives you 7 chocolates 2 times and then 7 chocolates again 3 times, then you can say 7 chocolates 5 times. So in the same way, half H is B1 times, half H is B2 times, and so on. So half H is these many times. Got it? Now, so this is, what is this? This is the area of all the triangles. And area of all the triangles is actually area of the full circle. So this is the formula for the area of circle. But what is H for the circle? We need to redefine these for the circle. What is H for the circle? Height of the triangle is actually the, yes, it is the radius of the circle. And B1 plus B2 plus B3, what is this? No? What is B1? This is B1. Then this is B2. Then this is B3, B4, B5, B6. If I add all the B's till N, if I sum them up, what is it becoming? See? If I add all of these, what will I get? Just think. This is actually called circumference of the circle, no? Sum of all the bases of triangle is actually the circumference of the circle, no? So we can say that half H is actually half R. H, height of the triangle, is the radius of the circle, and this is the circumference of the circle, and you know the circumference of the circle is 2 pi r. Now we can cancel this 2 with this 2, okay, and pi r into r is actually called pi r square. So area of circle is pi r square. So if we have to find out the area of any circle, what should we know? We must know its radius. Okay, so if we have a circle with radius 7, then we can easily find out area by this formula. This formula says area is pi r square. That means pi into 7 into 7. You know what is the value of pi? It's 22 over 7. Then radius r square means r into r. So that is the radius. Now here we can reduce it like this. No? So area is this. Okay? So if the radius is in centimeter, area will be in square centimeter. If radius is meter, area will be square meter. suppose this is centimeter, so the area here will be centimeter square. Okay, let's write it. What is this? What do we mean by this? That means 154 squares of side 1 centimeter can be made inside the circle. At some point there will be half square, at some point there will be 3/4 square, but in total they are gonna be 154 squares of side 1 centimeter. So this is how we calculate the area of the circle. So now we have formulas for area of rectangle, square, parallelogram, triangle and circle. Okay, so this is how we calculate the area of 2D shapes, two-dimensional shapes. This was all for this video. Thank you.